Hi, I'm Sri Vasireddy. I am the founder and CEO of RAIN Foundation. I'm looking forward to my presentation after this. I'll come back.
Hi, everyone. I'm Juan Jimenez, co-founder and CEO of AHA23.
Good afternoon. Tatiana Canzavelli, founder and CEO of Open Health Network. Glad to be here. Thank you.
Hi, everyone. I'm Jim Min. I'm a cardiologist and the founder and CEO of Clearly.
Hi, I'm Roger Ng. I'm the CEO and founder of Nobel Mind and Cardiology, working with an incredible team. Thank you.
Hi, I'm Sri Banerjee. I'm a doctorate and I teach for a living in public health. Thank you.
Hi, this is Domenico Cianflone from Milan, Italy. I'm a cardiologist and a player in the health IT arena since quite a long time, as you see.
And I'm David Albert. I'm the founder and chief medical officer of AliveCore, and I've been in medical technology for 40 years.
I'm Ashush Agarwal. I'm professor and chair of electrical and computer engineering at Rice University.
And I'm Mike McConnell. I'm a cardiologist, primarily based at Stanford, and I'll be starting us off. So I have my disclosures, particularly point out the industry disclosures in the lower part there. I'm an advisor for Toku Eyes, which is here with an exhibit, as well as Porter Health. And I recently worked at Google, Fitbit, and Identify Health. So, see if, there we go. So this is a fun session for me, and I appreciate the opportunity to be able to do the introduction. Most of my career has been in cardiovascular imaging, but more recently has been in digital health. And having a session that talks both about, has folks from the imaging world, the AI world, and I wanted to highlight, the FDA recently updated, all the device submissions that they've had for AI and ML-based devices, and as you can see, imaging and cardiovascular by far lead the list. If the type's a little small, it's because there's a very long tail there of things that don't move the needle very much, but the top two there, it says radiology and cardiovascular. So I think it's a great theme for the event, for this session. And really just, I wanted to touch on a few things. Pat, who is the boss here, said it would be good just to do a little introduction to what is AI. And I was an engineer a long time ago. So I don't claim to be, and as they say, it just makes me dangerous, right, at this point if I try to talk about this. But historically, AI has been around for a long, long time. We keep sort of changing what we think AI is, but there was actually a chatbot in the 1960s. You should go to the Wikipedia site. It's a great story. MIT professor wrote this. And there was a doctor script that emulated being a psychologist, and it actually was thought to be quite empathetic. Some of the things you hear today with chatbots, and they made freshmen at MIT in computer science write the doctor script up as part of the intro to computer science course. So, and then for most of the history, prior to when we get to what I call era 2, is the use of computers for clinical decision support. And I know Rob Califf, our FDA commissioner, was involved pretty early on. It was great to find this old editorial he wrote, The Doctor and the Computer. And there was some wise advice at the end of it that, the interpretation of use of computers depends as much on wise doctor as really any other source of data that we use. So, and then for anybody who rotated through Brigham and Women's Hospital emergency room, Lee Goldman and their team, using computer decision support to around chest pain patients coming to the emergency room. But I think where most of us think of AI these days is mostly what we now call machine learning, which really flips the model. Instead of humans sort of telling the computer what to do, machine learning means that you give the computer lots of answers and the computer sort of learns the best solution. And so you have a whole host of products, and I've tried to sort of highlight teaching about or reviewing a little bit of AI with a number of the members of our AHA's Innovator Network. So we have a live core, using ECG to help measure, QTC automatically. We have a couple of other ECG analysis companies. Sorry, I don't know why it went backwards. Cardio and AccuCardia. The AHA worked with both Apple and with Fitbit on their Apple Heart Study, Fitbit Heart Study for detecting atrial fibrillation from the irregular pulse from your PPG signal. And then there's a lot of interest in blood pressure and wearable blood pressure monitors. You heard earlier in the health tech competition, BioBeat has FDA clearance. Companies like CardiX presented, Hello Heart is also in the Innovator Network. There's obviously a lot of work around AI, many other imaging areas. CT, Jim Min presented earlier and is on the panel, so I'm not going to go into the CT side of it. I do have a particular personal interest on the retina side. We had published this in 2018 at Google. That was a great example where, they took technologies that were developed around identifying cats and dogs in your photos and said we could apply that to the retina. And so they gave it thousands and thousands of images of retinas with diabetic retinopathy versus healthy retinas and had the publication in JAMA. And there are now, 3 FDA-cleared diabetic retinopathy algorithms that are actually approved as autonomous AI. They do not require a physician or anyone else to review the images. So pretty high bar, but it means now it can be deployed in primary care. We publish on the cardiovascular risk from retinal images. And then, as I mentioned, I'm an advisor for Toku. And they have now FDA breakthrough designation for exactly trying to get that into a product that through the FDA. And then one of the other innovation network members, which does touch on the CT aspect, is MediWell. And they published on using retinal imaging to predict coronary calcium scores. So again, to try to help with prevention. And then the newest area, which is probably the area that I know the least, but I think we're all trying to learn and experiment with, is this generative AI, where the computers go out and they ingest as much information as they possibly can, and then try to generate answers from that. I hope that's an adequate description. And so, as you can see, every few weeks there's another component to these GPTs based on large language models. I think Elon Musk's company has a Grok, I think is the name of their generative AI. Google has a dedicated medical version of it, and I tried the latest ChatGPT 4. I uploaded my own coronary calcium scan. It says, yes, that's a coronary calcium scan, but I'm not allowed to say anything about it yet. So it has its disclaimers, but the idea that, we're getting to this era where, being able to interact with AI with your own personal information will be quite interesting. And I'm hoping next year's session, there will be a lot of companies and innovators and presentations on how we've been able to leverage this newest form of AI. And I'm sure there'll be discussion on the panel. So with that, I did want to say, the AHA Health Tech, go to their website. You can learn more about the Innovators Network, the Health Tech Advisory Group, and all the different aspects of health tech that they promote. And then looking for it, I thought I had, there it is. So I think we'll move on. Tatiana's leading our panel discussion. And why don't you all come up and we'll get going.
while my panel is getting on stage, if you guys on Twitter, you can see that I just did the real-time demo of latest version of ChatGPT. I uploaded image of Michael speaking, and I asked ChatGPT to generate a caption. And I didn't do anything, just picture and ChatGPT caption, hashtag AHA23. So under my Twitter handle, GLFCEO, so you can see what we're talking about in terms of capabilities. So you should see that. Okay, I just put the, okay. And yeah, it was real-time demo. Welcome to this exhilarating convergence of minds where the pulse of technology meet the heart of healthcare. Today, we dissect the future of cardiology with innovators who are not just in the race, but are actually defining the space, the pace of this marathon against heart disease. So we just went through introduction, so I'll skip that part. My opening question is, in a world overwhelmed, like brimming with all kinds of data, how you envision the role of AI and personalized technology in preventing the next heart attack? Easy question. I'll start with you, Dr. Dave. Michael.
Oh, no, I just...
Okay.
Okay. Well, as an old guy in digital health, having been in there for now almost 13 years, I would tell you, and having collected about 240 million ECGs from consumers. By the way, not every consumer is a patient, but every patient is a consumer. And the incredible insights that companies have on creating wonderful experiences for consumers is something we in healthcare are slowly learning. And so I think we're going to bring the insights that huge data, things like large language models, can bring to the measurement of any types of biomedical data, whether it's ECG or blood pressure, whatever, that enable us to develop some insights that might give us prediction. And in medicine, prediction can be prevention.
Yeah, I agree. I'm all about prevention, but prevention topic is not the most popular in healthcare.
I think, can you guys hear me?
Thank you.
Okay. So we have a company that was an offshoot of an academic spin-out. It was based on about 15 years of large-scale clinical trials. And what we hypothesized at one point was that all of these things that we measure in cardiology, doesn't matter, LDL, cholesterol, blood pressure, et cetera, that all sort of roads lead to Rome, and that Rome was atherosclerosis. That was the phenotypic manifestation of the disease. We recognize that heart doctors, like for the last 70, 80 years, have never actually measured heart disease at scale and for clinical purposes. And so we created a company to try to develop a care pathway that would allow for evaluation, education, treatment, and tracking of atherosclerosis. We recognize that some clinical questions were also important to address ischemia and stenosis, and so that's also embedded within the platform, but with a focus on atherosclerosis. We thought that it would be better to personalize medicine, and that would allow for better risk prediction, and then published a series of papers looking at predictive analytics to use machine learning to identify risk of heart attack, risk of rapid progression of disease, risk of medication non-response. And what we found when we dumped all the variables into a model was that it was always the disease features from imaging that were the most predictive, and that age and gender and race sort of fell out of the model. And so that gave us this conclusion that if you can measure actual disease, personalized evaluation, you can democratize care because you get rid of all of these sort of biases that are associated with what we see externally. So hopefully machine learning can help us integrate some of that with an actual focus on heart disease.
Beautiful, thank you. And I'm glad you mentioned certain demographical data that you're including, and I hope at some point of time we'll be able to integrate environmental data, stressors, and other things that impact, considering the same level of predisposition of certain progression of disease, what else can impact. Thank you.
So I have the pleasure of being an engineer and seeing where the technology front is. I would want to mention there are three main trends which are coming. If you look at all the presentations, they are about data and where we can acquire what type of data. That frontier in engineering is moving really fast. So as an example, what you can measure where, there are technologies which are coming which will allow cellular type analysis on your wristwatch. That means we can probably put a microscope on your wristwatch and build apps to do biomarker analysis on your wristwatch. So that's a very fast moving. Within the next decade, you will start to see products which will do that. You mentioned stressors. So actually, there's a lot of talks about how behavior impacts biology, but we actually don't know how to measure most of the behaviors. Our crude behavior measures are steps, sleep, so on and so forth, but there are quite a few other stressors. So there is a whole body of engineers who are looking at quantifying human behaviors, both at the observable levels and at meta levels. And that's really exciting research. Perhaps 10 years away, but it's coming around. And I think we already mentioned the idea of large medical models where you can actually ask it many questions, not just trained for one specific purpose. So I think there is a whole host of technologies which are on the frontier. Some will appear in 5 years. Some will appear in 10 to 15 years.
Thank you. Juan.
Hi, everyone. Can you hear me?
Yep.
So I believe to prevent the next heart attack is a multi-step approach, and there is no silver bullet. I believe that what we are contributing to society in my position is to create a platform that can ingest data coming from ECG data from consumer and clinical devices and deliver information for doctors and clinicians to properly assess those patients and help them in prevention. So I believe that that's the 2 cents that we can provide to this topic, and I believe there is a multi-sector approach, and we will need the help of all these panelists as well as you in the audience.
Okay, I'll add my 2 cents. We have a little bit more time, so I'm injected in. From my futuristic point of view, I think that when a child is born, we'll do complete genetic analysis of the child, parents, will understand probability of certain things inherently based on genetics, and then we'll help to map out the lifestyle and everything else based on highly personalized information that comes from genetic, and hopefully focus on prevention from things from escalation. And with the speed of innovation that's happening right now, I wouldn't be surprised that it will happen sooner than later. Now we're moving to our deep dive section, and I'll start with Dr. Dave. So and I've seen all the gadgets, all those amazing devices that Dr. Dave and LifeCore has been developing for many, many years. And it's just fascinating, the progress and development of those smart devices. So what's the next frontier for patients monitoring their heart at home? Yeah.
Well,
it's a credit card that will give you money.
Well, our whole view is increasing access, taking healthcare to the home, to the person. Jim talks about individualizing, in essence, the level of disease in coronary artery disease, critically important, because today we have amazing therapies, and they are, this morning, the SELECT trial. In the optimally treated patients, these new drugs, these GLP-1, weight loss, diabetes drugs made a huge impact. That's amazing. And oh, by the way, that isn't the best GLP-1. So we're going to be better. Well, that means we have to identify patients. We have to identify their stage of disease. We have to get better at identifying people. And that's going to come from huge amounts of data that are sifted through, like these large language models, utilizing biometrics, demographics, all the affix, in order to help us say who needs to go to the next step, who ultimately needs a CT angiogram and a Clearly study, who needs, a personal monitor for continuous monitoring. and I think, that's the promise, and I'm fairly confident that that promise will be realized.
Thank you. And you rightly mentioned that we have all that massive amounts of tons of data, and I think there are two angles to it. One is to be able to analyze it, but I think the bigger question will be for us to be able to state questions in the right way, and that's where usually the issue comes. It's not prompt engineering, it's just like how you formulate what you're looking for so you can mine data in a way that will help you to solve. Of course, there is another aspect, but we don't have too much time, so I don't want to go off. Question for you, Dr. Min. Clearly has been a leader in imaging for cardiac health. How do you see imaging evolving in the next 5 years in the fight against heart disease?
I think we focus on CT angiography mostly. I think you've seen a lot of technological evolutions in echo, in MRI, ECGs. I think you're going to get to the point, it's at the point where the technology is superhuman. It's better than the doctor. We're going to have to figure out how we work with that. I think we're going to have to figure out how we're going to implement that in the workflow in a way that is value added to all of the stakeholders, the patient, but also the doctors. And I think thinking through not only what the day-to-day work looks like, but how does that expand the pie for the healthcare system and make sure that everybody's made whole. And I think there's still a lot that we don't know. From our personal perspective, like Deepak Bhatt was talking earlier this morning, we believe in the randomized controlled trial mechanism, so we announced a trial that we're starting today. It's called Transform, and we're going to spend the next 5 years doing a large-scale 7,500 patient randomized trial to prove that we should be using imaging to screen for heart disease similar to the way we screen for cancer. So at least that's our own personal path for the next 5 years.
That's super exciting. Good luck with the research. And from my point of view, being an educated patient, I always try to see if I can get a hold of the data that you guys have. So especially now where I can drop images into generative AI and get interpretation. I don't know if that will be at some point even visible, but I think it's fascinating. And the imaging was on the forefront on everything AI for a while. Dr. Sabhavar, from engineering perspective, what innovation do you believe could be a game changer in preventive cardiology?
First of all, thank you everybody for taking care of my heart. It's good to come to this conference, see what's going on. I'm going to talk as a common person, as a patient also, who actually has a heart problem and has to take care of him. I spent many years in denial. I think I can delay it till I bought an Apple Watch and started to monitor it. And I think if there was a middle point where I can get more data in an easy manner, more continuous data where I can actually have validated measures to understand it to the doctor, I think that could increase more participation in people's own health. And I think that motivation could also change depending on if we can make these variables. So there are at least 2 platforms which are currently widely adopted. One is a smartwatch platform, as in like 80% people wearing it here. The other platform is what continuous glucose monitors, which are very slightly invasive. Both these platforms are really moving very fast forward. So if you look at the optics behind it, it's basically only 2 LEDs with 2 photodetectors. What people are working right now is putting a camera at the back of your wristwatch and doing a cellular level analysis on your wristwatch. And I think once that makes it to the market, where I can actually track different biomarkers, maybe cumulative biomarkers, in early stages. So that means my overhead of self-care is buying a watch, which will last me for other purposes. then I have a feeling there'll be just more participation in everybody's taking care of their health. The other platform, which is CGM-based platform, allows multiple markers to be actually tracked. So it could be BNP, it could be other markers. And those are also on the horizon. Some of them are getting commercialized. That would, I think, help take care of ourselves, especially for heart failure. If I'm at risk, I would like to wear that, that's a CGM-like device for BNP and stuff, so that I could wear that. I feel like these two hardware devices or platforms could be very useful. Rest, I think, will follow by inventing new clinical workflows.
Yeah. This is funny. In my view, I'm trying to create a prompt for ChatGPT, creating an image of a patient wearing all those devices and getting all the data in trying to improve the disease. So that's coming. After the session, I'll create a prompt, follow AHA23 hashtag. Thank you. Beautiful vision. One question for you. Acocardia is at the cutting edge of cardiac care. How do you see technology changing patient outcomes in the near term?
At least in Acucardia's phase, I believe that in the next 16 to 18 months, as we deploy our FDA-cleared ECG analytics platform, we will be able to help physicians and patients get their Holter, event monitor, and MCOT output faster for early treatment. I think, secondly, we want to enable cardiac monitoring companies to be able to do more with the data they are getting from patients. And I believe that in the near future, we are going to be able to ingest data from all these devices, consumer and clinical, summarize it and present it to a physician in an actionable manner. Because nowadays, having too much information is having no information at all. And based on that, we are trying to solve that in the ECG front, but I believe that is going to be translated to other areas of care so we can get that information presented to physicians and clinicians in a way that they could act upon and not be drowned by that data.
Thank you. Beautiful. Michael, I know you're not official part of the panel, but your 2 cents.
Is this working? Great. Yeah, I think what everybody said resonates a lot with me. And when you were asked, what can we do to better fight heart disease? So you probably saw there was a disclaimer on my disclaimer side. I wrote a book, Fight Heart Disease Like Cancer, and I've loved that Jim's description that, and as Dr. Dave said as well, we have these incredible tools and therapies to detect disease, to treat disease, to prevent disease. What we're not doing well is identifying people early enough and showing that whole pathway of getting people identified, get them screened, and we do that naturally for cancer, right? I hear stories from friends, their doctor looks at them and says, you look fine, why do you need any checkup of a calcium scan or anything? And I'm like, but you wouldn't do that for cancer. You wouldn't look at somebody and say, you don't need a mammogram because you look fine. So I really think the pushing out technologies to consumers like ECG, broadening access like the retinal imaging where people, when they get their eye exam, can have their cardiovascular risk assessed, and then really appropriately personalizing and tracking therapy through imaging, that is really the future. We need to move to more of a cancer model for how we approach heart disease and get people forget that it's killing more people than cancer. So, yeah, so I think all of what you guys have talked about has really resonated.
Thank you. Now it's my turn. I started my company, Open Health Network, with Dr. Tsvetavat many years ago, at the exact time when I was diagnosed with cancer. So at that time, when I stopped planning my funeral, because, it's cancer, it's pretty bad. Being a data scientist all my life, I started entertaining the view of how all kind of data, and we mapped 360 degrees of data points that can help us to predict and prevent and treat all kind of, chronic diseases. So when I asked why me, no one could answer because it wasn't even genetic. I couldn't even blame my parents, right? So there was something else, and it all like, you're not lucky. So 10 years ago, I was speaking loudly about all kinds of data that can and should be used in healthcare that no one was paying attention. So I'm glad that we're moving, and this is like a mainstream topic. My heart is dancing. We're working closely with many healthcare companies, but our long-term vision is using all those massive amounts of data to create a digital twin. So there will be data-driven representation of you. And the opportunities with that model, all the way from prevention to treating patients and everything else, is enormous. And you'll be hearing more about it with some set of press releases. So I'm glad to be here and moderate this exceptionally timely topic with experts. Now time for cross interactions. So the question is, let's pivot to crosstalk. How do you see your technologies integrating with each other to create a holistic solution for the patient? As I mentioned, it's like tons of stuff, and poor patient doesn't know what to wear, where to look for data. So let's discuss that, open discussions.
Well, maybe if I can start, I just want to dovetail on what Mike said, because I think that he made an analogy to the, hey, you look fine, you must not have breast cancer. And it just, I think about it from the perspective of coronary heart disease, which is what we focus on. But I just remember as a fellow getting trained 20 years ago, what we were taught was that it was the symptomatic patient who came in with chest pain who was at risk of a heart attack, and if you could relieve the symptoms, you'd reduce the risk. Well, we've proven that over and over and over again to be untrue, right? What we do is we relieve symptoms and we do nothing to risk. So what we ended up doing was conflating two questions into one around symptom relief and one about risk reduction. And I think now we're at a point where we have enough evidence to say, okay, the risk reduction question is a different question. And when Mike was saying this stuff, it got me to thinking that I think as a field, we need to shift away from a really symptom-driven paradigm to a disease-focused paradigm. And the last thing I'll say that came into my mind was that all disease is asymptomatic until it's not, right? And so and given that 51% or 52% of people will suffer or die a heart attack with no antecedent symptoms, we should focus on disease rather than symptoms. I think that's where you're going to see the crosstalk here, because all of these companies are looking at disease rather than symptoms.
Yeah, I want to add, I love the way you framed it. How I would love to add, we need to focus on a patient, then disease, then symptoms, right? Because patient is more than a disease, more than one disease. Okay, let's continue our crosstalk.
I would tell you that, just like Jim said, if we focus on you as a patient and your disease, and we tailor our therapies, today that's a future. That's not where we are today. Today we wait till things happen.
Yeah.
We have to give you a stent, an implantable defibrillator, a TAVR. We wait until they and by the way, that's where all the money is today. So that's what keeps those big hospitals open. But inevitably, whether it's genomics, whether it's imaging, whether it's biomarkers, we're going to be able, whether it's drugs like GLP-1s, we're going to be able to finally prevent and do so economically. And the real question is, what happens to the ACC and the HRS and the AHA when the prevalence of manifest heart disease starts to drop? Because if we do our job right, it will. And so that's going to be a very interesting data question. Because remember, when they tell you it's not about the money, it's all about the money.
Yeah, I would say that will be a super cool problem to have in hands, what we're going to do with all those people. But I have a follow-up, and again, open discussions. So you're basically saying that it's my responsibility as a patient to focus on prevention because everyone else, you both said, focused on sick care, and we're want to move to healthcare and prevention. And it seems like you're implying you will give me as a patient all that data, so it's my responsibility to prevent bad things from happening, right? Comments?
I'd like to build on Dave's point. If we want to reduce the prevalence of heart disease, it's going to take all of us and all of the people around to work on the problem. And I believe collaboration among different players in the ecosystem, including technology companies, is essential. By contributing the strength of each other and complementing each other, we're going to be able to help address the problem at hand. I envision a day in which data coming from clinical and certain consumer devices could highlight certain features that recommend for a particular prescription for the LifeCore device, and to better manage and monitor that patient. And based on that information, then that patient is referred to clearly for particular testing in imaging for atherosclerosis and other conditions. So I think the more that we collaborate amongst ourselves, the better for overall society and to be able to reduce the prevalence of heart disease in America and the globe.
Excellent. We have this huge audience here listening, so you'll hear all our points of view. So if any of you want to collaborate with us, please get in touch and use this time to collaborate with each other, because that's how we will come to the place where we all can combine our efforts, because we have the same goal, keep everyone healthy. Any more comments on our...
There is a recent paper I read. I thought the title was very apt. It says, genetics loads the gun and environment pulls the trigger. And I think, there are, even if we do everything right, there is a certain upper threshold we will reach on how many, heart attacks we can have or not prevent or so on and so forth. So eventually it becomes a much larger problem than what healthcare can solve by itself. And I think there is work going on in Europe where they are looking at cities which are designed or thought so that you actually have healthier individuals. And I think that collaboration might be actually worthwhile thinking simultaneously while we are discussing all the other really important point solutions. The built environment has a huge impact on health.
Beautiful, Michael.
Are we doing questions?
We're doing, yeah, just you have 1 minute to comment on this.
Oh, okay,
Topic.
sure.
Okay.
Yeah, I think what we're excited about is we've got a lot of technologies that can help sort of expand that funnel, that are consumer friendly or where people are going to get care, that may not be through their primary care or other situations where they can get detected at increased risk. That's why, on the imaging side, there's work we heard earlier. People get CT scan for one thing, and that gets shown that they have coronary calcium on it, or the retinal imaging we talked about. There are publications now predicting cardiovascular risk from your ECG. But, to me, that then hopefully expands the funnel of people who then get the full guideline-based care. And as we've been saying, the blood vessel really is sort of the final common pathway of where these numbers add up. And being able to look at the blood vessel, see that there's disease, which becomes very motivating for patient and provider to then use these powerful therapies we have for prevention. But it's a lot about broadening the funnel, early detection, and then effective treatment.
The pediatricians are the guys that they're the people who are the front line of prevention, because you don't start it when you're 68 years old. You start it when you're
68,
6
kidding?
or 8 years old.
We have time for a couple of questions from the audience. When you raise your hand, please state your name and your affiliation and ask your question. Oh, no, we can't hear you.
I think we can get closer.
Taya Glotzer. I'm actually an electrophysiologist.
We
but I
can't
wanted
hear
to
you.
say, I'm an electrophysiologist. But I wanted to say that I think, we're beating ourselves up a little bit. I mean, we do lipid screening. And based on lipid screening, maybe we order coronary CTAs. So I think, my question is, how much data do you want to give a patient to say something bad is going to happen to you unless you know what to tell them to do to prevent it? Because otherwise you're just going to scare them and say, your EKG shows you're at risk for this. I mean, I think we need to know what we're going to do before we tell people they're at risk, because otherwise you're just scaring them.
Any comments? Any comments? Thank you.
Yeah.
Did you hear a question? Okay.
I think that's a really good point. Think about the last 15 years of looking at every front cover of Jack, and I can predict almost all of the start of the title. Can you hear me? Yeah. If you look at Jack, it's every week. It's like the prognostic value of XYZ, risk stratification for ABC. It says hazards ratio for this. All we do is find stuff that predicts death, and we say, okay, now what? That's your point. Like, what? How do you now treat? It's got to be actionable, right? Otherwise, we get all these data points and say, gosh, you're going to die, and say, okay, well, doc, what do I do about it? I don't know, man, but you're going to die. Like, that's just not helpful to anybody, right? But the glory, at least for coronary disease, that's the world I sit in. 10 years ago, the late George Diamond, he said, we don't need imaging to screen because we can just treat everybody with statins. It's simple. That was true. I think that was a legitimate argument. Now we don't have just statins, right? We've got SGLT2s and GLP-1s and rivaroxaban, clopidogrel. Like, the list just goes on and on and on. And it's too expensive and it's too much polypharmacy. We're not going to be able to do that. The lipid screening doesn't work, right? Like, I mean, if you look at the Jack papers of the prognostic XYZ, the patients presenting with first myocardial infarction, 2/3 of them have normal cholesterol levels. Like, it's a good group-based biomarker to find a healthy group versus a sicker group. It's not a good individualized, personalized biomarker to figure out who's got actual disease or not. And then on top of that, when you treat it and you lower cholesterol and put them on a statin, you've done a 20% relative risk reduction. So then we pat ourselves on the back and say we did a great job, but that implies an 80% residual risk. So it's just not going to ever work. The other thing that I've thought about a lot is that when you look at where people suffer or die of heart attacks, they don't do it in our cardiology prevention clinics. They do it at home. And they do it at home with a non-negligible proportion not having any symptoms, any risk factors, not seeing doctors. I think we got to go upstream. If we don't go upstream into where the patients are, we're never going to make a dent into this public health. So I'm not trying to beat up on the field. I just said I think that we've got technology and we've got 20 years of vascular biology on imaging that helps us to understand exactly how to identify people, and then this blockbuster heavy toolbox of medications that can really save lives. Now we can really pinpoint who should get those therapies.
I remember 40 years ago when we started this about symptoms. When we moved from thinking myocardial infarction was due to 95% lesions that then got a clot, and then we found out, no, it's due to 15 and 20% lesions where plaques erupt and cause thrombosis. And a lot of people thought, that's crazy, because people come in with symptoms, we treat the symptoms, we treat that, but they didn't have any impact. We've got to treat the disease, not the symptoms.
Well, that's why classically, right, you brought this up earlier, you can put a stent in a spot where there's a stenosis, but it's like cancer, right? It's like taking out a tumor, but there are metastases everywhere else. And you've taken care of that one problem, but you haven't treated the disease, and you have to shift to treat the biology, which is what's killing you in the end. The mechanical is an issue, but that's not the primary issue. But I would argue a little bit that our current system of where do we think really everybody is getting an ASCVD risk score, and when they're at 5% that they're getting a coronary calcium scan? I'd say that's maybe 5 to 10% of the entire U.S. population follows that pathway, and yet that's what the guidelines have been for the last 5 years. And so that's why I put in the book, if you're a 50-year-old man, 60-year-old woman, you probably should be on a statin or have a 0 calcium score. And if that's not the case, you should know your numbers and get checked. So.
Yeah. Any comments? Any other questions? Okay, thank you.
I don't, oh, okay, thank you. My question is about how you get to people. So it's about trust in the technology, and it's about reach out, and it's about opportunities or access to all these technologies. So are the companies proactively, working to gain the public trust? What needs to be done? It's companies, it's educators, it's everybody in the industry. Is there enough funding and enough time and enough energy to do that? Because if you don't reach and you don't get public trust, it will be very hard to do what you rightfully say to do, to go to patients' homes and to reach patients one by one. Thank you.
Okay, the question was how we
future
can
is
get
here.
to all the people.
The future is here. It's just not evenly distributed. Most people don't have access to a clearly analyzed CT angiogram. State of the art. So we have a long way to go. I mentioned prevention will decrease coronary disease. I'm not worried about my business. We got AFib's going to go from 6 million to 15 million. So we have a lot of things to do that are basic, and I think access across the world is a huge hurdle.
I can tell you, from my point of view, I know my history, family history with heart disease. So I went to my cardiologist and PCP, and I said, give me a prescription for calcium scan. I paid it out of pocket. They wouldn't put me, despite the fact that I have cardiovascular on my mother and father's side. So I assessed the need, and I had to pay out of pocket. Why?
Yeah, well, we haven't done the big screening trials, right? The NIH funded the predictive trial, the MESA trial, and has yet to fund, an equivalent of a mammogram or colonoscopy broad screening trial.
If the NIH is here and they want to fund our screening trial, we'd be happy to take the funding.
Yes.
Maybe I just make two things, like the comment that you made around trust. And so when we developed our product suite, like what we said was, let's take all this fancy imaging stuff that nobody really cares about, and let's make it clinically actionable. And so we made it like red, yellow, green, so you could, I showed it to my brother, he was a primary care doctor, and I said, do you know who's sick? And he's like, yeah, I get it. The red guy's sick and the blue guy's not. But we just said, it doesn't, you don't have to brag about AI. It's just a tool that we use to make the product. But the delivery to a healthcare professional doesn't have to be embedded into that. And the flip side of that coin is that I think as a field, cardiovascular medicine has raised the evidence bar across all medical specialties. And I think that any question worth asking within the context of AI or any of these new technologies is worth asking within the context of a large-scale multi-center clinical trial.
Tatiana, I'd like to add something here on the question about trust. I think clinical evidence and going through constructive regulatory process to certify or clear certain technologies is essential to bring trust for patients and the general population. But in terms of access, I like to add two things. One is cost. We need to build technologies that are cost efficient in any zip code in the nation, as well as most of the globe. And I think it's by analyzing the cost and making sure we use the technology to bring down cost and access is essential for broad adoption of these technologies. And then one more point is technology that is able to interconnect and compatible with multiple devices. I think in general, building technology that only work with a certain cluster of information or settings prevents broad adoption and access, and thinking about that perspective of access is, I think, is essential to solve this problem that we're at hand.
Thank you. We're unfortunately out of time, so for next year, ask for this AI panel to be like an hour and a half. Thank you, distinguished panelists, and beautiful, engaged audience. And let's move forward. By the way, all my questions, even specific ones, in my talk has been generated by ChatGPT. Thank you.
Like this. Hi. Hello. 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 Great. Hi, audience. Thank you so much. I'm the CEO of Noble Mind. I'd like to also thank the panelists as well. I think a lot of the things that they said actually made a lot of sense. The ability to be able to understand the disease of the patients and how they present is really the most important aspect of getting to treatment of disease and treating your patients. When my grandmother died, that actually was the beginning aspects of me and my journey to cardiology. It allowed me to understand something really important. Throughout training, one of the things I was able to actually integrate together was the ability to be able to understand the patients incredibly well, to integrate the ability of being able to deliver invasive intervention as well as compassionate care. That aspect of it through training actually helped me understand one major thing, which is the ability to understand the patient and be able to decide that. That understanding actually helped me actually treat my patients better, and that understanding also was able to actually help me deliver customized care to actually all of the patients. And that was the understanding that I actually wanted to be able to put forward into healthcare and be able to help patients and help a lot of patients. Unfortunately, a lot of the stuff that we do in healthcare actually doesn't translate well to patient care. As you can tell here, a lot of the times that I spent for patient care, about hours a day, sometimes into the middle of the night, probably translates to only a couple of minutes of patient care during the day. And in fact, it's actually probably slightly worse than that. The time that I spent on patient care is probably spent on time on patients that actually had made it through the funnel that probably didn't actually need me. And therefore, only 5% of the time that I actually spent on patient care actually directly went on patients that actually needed a cardiologist. It's even worse for patients themselves. For patients that have actually trying to make it through the funnel, they actually bump into a maze of problems, a lot of hurdles that they have to go through. And it's actually not a secret that a lot of the healthcare and all of the communications and call centers don't make it very easy for patients to actually make it through. So therefore, this is one of my patients. By the time the patient actually presented to healthcare, what happens is that it is already quite late. Claire was actually sent to me about 2 months ago. She was referred for a family history of early onset heart disease, pretty extensive atherosclerosis in the family. But she had a prior history of asthma, and the family history, and the primary care providers themselves have actually diagnosed her with asthma several times. In a busy clinic in my day, I actually saw her. She had actually just gone through a couple of treatments with upper respiratory tract infection. And in addition to that, she had actually had some wheezing in the clinic. I diagnosed her with asthma in a busy day, unfortunately, as well. Obviously, over the course of the year, she doesn't do very well. She actually comes in multiple times, seeing physicians, getting more tests, only to discover that she actually has significant coronary artery disease, which eventually resulted in multivessel bypass surgery. I believe that if we truly understand her disease a little bit better, integrations with a lot of the technology that is actually available now, we would be able to understand both symptoms and disease as well. In the course of the last century, there has been multiple revolutions that have occurred that dramatically changed the standards of life, improved humanity. And I believe AI is actually that next step. Not using AI in healthcare, it would be actually like not adopting the internet at the time of 30 years ago. I'd managed to start an incredible company with No More Mind because I actually believed that AI would be transformative in healthcare. And in that particular respect, be able to tackle a lot of the things in the community. AI itself has the ability to be able to actually project a lot of the data on patients and be able to put the entire population of the patients in a curve, and therefore be able to understand a lot of the disease states of the patient at their particular states, and allow us to be able to act on those particular patients and bring them back to the curve. In addition to that, we would be able to actually transform and change Claire's trajectory and be able to move the trajectory in a much more healthier pattern. I founded No More Mind with great people, technologists and world-class AI companies, healthcare experts to build customized AI solutions and built a multi-centered effort. In addition to that, we're working on a big vision, a vision to be able to bring the right patient at the right time for the right care. Currently, what we see here is a lot of data on multiple windows of panels. This is kind of what we see. We have to navigate a lot of data, and a lot of that data is buried relatively deeply. Using our system, we're actually able to ask a single question, and it sifts through all of that data for us. Being able to do that allows us to actually have a physician tell us what each of those patients mean from hundreds of pages of data. Sorry, the slides are moving without me. That's a little bit more AI than I expected. But essentially, what we're going to be able to have is a conversation with AI, and AI will have a conversation with your patients. And by the time that the patients actually present to their first encounter, what you're going to be able to have is data that will be summarized for the doctor. By being able to do that, the doctor will be able to act on the patient far more in depth and far more informed than they currently are. Thank you so much.
Click. All right. So my name is Sri Vasareddy, and we're a foundation, and we're very focused on public and population health. And in general, we talk a lot about inequity in access to healthcare. Which is getting a patient to a doctor, which is a very important aspect, and that's where the money is. That's what we talked about. But those in public health understand how difficult it is to bring that awareness to seek that access. There is little money in that, but the real outcome is dependent on adhering to the advice, and there's even less money in that, right? So what we have done is we have created very patient-centered and health worker-centered building blocks. From a patient perspective, managing the vitals, symptoms, and medication, nutrition, physical health, and mental health. And from a health worker perspective, removing the paper forms that they use, digitizing them, and risk stratifying, and bringing this information together for this value proposition. So if I'm going from one visit to another visit, what happens in between those two visits so that I don't depend on anecdotal information? So if I'm asked a simple question like, have you been taking your medication? We all have recency bias, and we may not be answering it with all good intentions, not answer the question properly. So what we do is we bridge that gap with different AI, and I'm going to talk a little detail about how we apply AI into each one of these sectors. By the way, this is the example of what we built. Our platform powers the Heart and Stroke Helper app on the leftmost side for you. And And that same app can be consumed in multilingual languages. Like I said, and if anybody is interested, right after this, I can stop by, and in any language, you can ask a basic question related to hypertension or diabetes or any risk. And then we take the AHA's protocol-based management of care and deliver that as messages. And we start keeping track of, have you taken your medications, incentivize them to do that, for that behavior. And the rightmost is the community health worker capability. That's an example of that. So where we apply AI is the generative AI is initially the basic question and answer to build that awareness. So I may not know that I have hypertension just because I'm not facing any symptoms, or I don't know those symptoms are because I have hypertension. But create that awareness by at least getting them to do one blood pressure check, bringing that awareness in them, and then give them freely to be able to ask that question. And then another good example is nutrition. They can just give an utterance of what they ate, and we automatically derive and understand what they ate and keep the nutritional facts. And it can also act as their personal nutritionist, so we can give them a recipe of what they should eat to mitigate their current risk, like if it's anemia or something else. We have intelligence around care plan generation. So we use GPT to generate the care plan, but it's a verified plan that we then put it on a personalized LLM to deliver that. And the last part of it is more from a statistics perspective. Rather than building preset dashboards, you can ask simple English questions like, I want a trend of so-and-so, just like how a doctor or a health worker would want that information in, and we understand English and deliver those results for them. Right? Those are good examples, 4 good examples of how we use generative AI in our platform. And our entire platform is open source, free for anybody to use. If you're interested, please let me know. That's my contact information. Thank you.
Okay, good afternoon again. It's a pleasure being here for another time in this Health Innovation Pavilion, and thanks to anyone. As you understood, my name is Domenico Cianflone. I'm a practicing cardiologist. I'm also a player in the health IT arena since several years. And, okay, there they are. I'm going to explain a couple of examples at the dawn of AI. I will say archaeology, machine learning. These are my conflicts, and this is how the publication in artificial intelligence in medicine have been for decades. I selected 1989 not because of Stranger Things, pun intended, but because of a couple of interesting things happened to me in my life that I perceived very important. Well, actually, the first close-up photo of Neptune's with the Voyager 2 probe, the collapse of the Berlin Wall, I got married and still am, and I got a crush with a piece of software, with a mathematical simulation of a backpropagation neural network. And the niceties of this solution thrilled me, because actually the functioning of a neuron with the multiple stimulation or inhibitory patterns and through a transfer function produces an effect. And the equivalent calculation is like a sequence of variables that in mathematics is a multidimensional vector could produce with a sort of black box, the matrix, another sequence of variables. And applying a pattern saying, okay, this is the input, the sequence of variables, and these are the, I don't see whether a pointer is, but you see the output layer. and comparing it with the difference in expected values and back propagating the error in order to have a standardized machine learning network in between, allowed us back in 1990 to experiment with some neural networks. The first one was meant to predict the site of a significant coronary stenosis from myocardial perfusion scans, and the second for the interpretation of exercise stress test. The first network was analyzing the 17 segments as perfused, not perfused, reperfused, and so on. Slides are going on their way. I'm sorry. I'm not pressing anything. Okay, I'll tell you. And we were able, after several hours, 30 hours of having the network converging. That means back propagating the error until reach the steady state, something like the sigmoid function of the Bayesian curve. So close to a steady prediction. And the second network was meant to understand, to predict what was the most probable responses to an exercise stress test, taking into account the age and gender, the presence of coronary active treatment, the maximum workload, the heart rate, the blood pressure, and the J1, J2 levels at 12 lead ECGs in order to understand ST depression and the slope. Eventually, after a set of training and a set of validation and a convergence that lasted 14 hours, I don't understand what's happening, and eventually we had quite a significant combination of what the very early machine learning did according to, and there is also a pointer, it's not me, something is happening, okay. And eventually an expanded neural network was published. On the next slide, if I can get it, we challenge a more difficult problem, trying to assess with a very early initial artificial vision neural network the ejection fraction from left ventriculograms. So instead of having a sequence of variables, we had a matrix of more than 3,000 inputs corresponding to the grayscale. We did that through a sequence of processes, getting DICOM images from the very early quantitative coronary angiography system, saving as TIFF files the frames. TIFF file is a very peculiar text pattern decrypting the images, so we could do a subtraction of the end diastolic and then systolic frames in order to determine the area changes. I don't know who's changing my slides, I'm sorry, to detect the area changes, and we were able to predict the ejection fraction after several hours of training within 10% on 70% of the cases and within 5% on 20% of the cases. Another experiment some years later tried to assess the relationship between multiple risk factors, analyzing, and that's a larger network, out of more than 5,000 patients. And we obtained, after 18 hours of processing, an entity relationship chart of the different components. The image, if I can get it, okay, is a low resolution because it's the original. And we were not teaching what the relationship according to the different parameters were. But some very interesting things spontaneously came out at that time. Like, for instance, the relationship with fibrinogen and physical activity, or physical activity and the heart rate variability. Quite interesting at the time. All that was done on a personal computer of those times with a mathematical coprocessor, 400,000 transistors, 1 megaflops, but I wonder what we could do with the current latest chips that are on a network with 10 times 10 million times the capability of computing. Let me conclude this very short and cumbersome presentation with two key points that we wrote together with my friend Patrick Dunn here. The power of machine learning depends on the quality of data. So we have to stick to something that we can rely on. And we need more and more research in order to adopt the most appropriate tool for applying to medicine. Thank you very much.
Hello, everyone. I'm Dr. Sri Banerjee, and in this. No. Oh. So this is I wanted to present a machine learning model that we created. Dr. Patrick Dunn, and then Dr. Conrad, and Dr. Roger. I'm not sure where he is. So we all worked on this together, and what the premise was behind this paper is that we generated an AI, a classical AI model, a random forest model, and one of the individuals said that prediction is prevention, and I think that's a nice way to understand where AI is today and how generative AI will make a difference. But our question is, do we just dispose of what is there, or do we work together to explain to people how the future of AI? How do you push this? Oh, there we go. So this is the paper, and we just published this. This was a nice article about how to combine, and we've been meeting for a while now. And this was actually the second paper in the series. The first paper Dr. Dunn actually wrote. So we're advancing our model and popularizing this. What we used here, this is the R code. This is kind of the black box that we were talking about, where we were working on kind of to modify this. And so this is where we created this R code. And as you can see, this is the National Health and Nutrition Examination Survey. And we took a large data set, such as NHANES, and created a random forest model. So I'm going to show that throughout these slides. So the main question that we asked is that if we have depression as a risk factor, so what is the combination of mental health and physical health? What's going on here? So here, let me show you. So this is kind of behind the scenes. This is what's happening. Lambda, we had to understand Lambda in terms of, in order to make a random forest model. So this is the predictive average systolic blood pressure. So the blood pressure was taken 3 times, and then the mean was considered. And so not only does it have the power, AI have the power to create these classifiers, like I showed, it also has the a capability of actually creating what predictor is most important and what predictor is least important. So age is something that you can kind of, always age is something that will be a strong predictor. However, what is important is that right here, I don't think this is not. As you can see, household income. Income was something important as well. And then consuming alcohol. So substance use, education, race. In logistic regression, or a lot of the statistical tests, there is no way to understand the relative importance of each of the variables. So this is what is called is a mean decrease in Gini. And as you can see, actually, depression was, this is not really clicking as, oh, there we go. So as you can see, after employment, depression is a huge predictor for mean systolic blood pressure. So this is a gradient boosting algorithm. This is considered ensemble learning. So you're combining a lot of different classifiers in order to make one. This is not the same thing as deep learning, as neural networks. This is random forest, that is another machine learning. And then this is boosting the gradient. Now we're asking predicting diabetes in this other model. And again, this is what predictors in National Health and Nutrition Examination Survey. Again, if you eliminate age and income and education status, because those are demographic variables, then you still have marital status, race, and depression. Those are that are important. Predictors of diabetes, this is the original R code that we wrote together. And then now predicting depression, this is another model. Age, again, alcohol was second highest, and then household income. So conclusion, cardiovascular disease as defined by blood pressure is associated with the occurrence of depression. Boosting, such as adaptive boosting versus gradient boosting, provides superior predictive capabilities as per confusion matrix. So what I wanted to close with is what the fundamental question was in our paper, and that was, do we dispose classical AI with, and when generative AI is becoming popular? And the answer was no, you cannot eliminate anything. You just have a conglomeration of what had gone on earlier and what is going on now. Thank you for listening.